Hello everyone. In this video, we're going to go through inheritance in Java. We're going to do an example of a general publication class and then more specific derived classes of publication like book and magazine. To do this, I'm going to use IntelliJ IDEA for my IDE and make a new project. I'm going to call my new project Inheritance Fun. All right, we're going to have quite a few classes in this example. Let's start with our tester class, and I'm going to go with publication tester for the name because, as I just mentioned, the theme for our inheritance demo here is publications. All right, so we're first going to put in a main, and I'm going to come back and take some notes here. But first, I'm going to make publications so we can see what does a general publication look like. All right, so publication is going to represent a general publication, something that might be distributed in writing. And it's going to be a very simplified example. So I'm going to have 4 fields here. So the first one is going to be title. And I'm going to set its access modifier to be protected because protected means accessible by any subclass, even a subclass in a different package. Now, I'm not going to be working with a different package in this example, but the first part of that definition is important, accessible by any subclass. We're going to subclass publication to form an inheritance hierarchy, and I don't see a reason why my subclasses of publication shouldn't be able to access the title of their publication. All right, so a few more. Let's do a protected string publisher, a protected int num pages, and a protected double price. All right, next we have our constructors. So I'm going to do a DVC first. Recall this stands for default value constructor. So a default value constructor doesn't accept any arguments for values to initialize its fields to. So I'm just going to initialize each of my fields to kind of dummy values. All right, next I'm going to have an EVC. This stands for explicit value constructor. So with an explicit value constructor, we are going to pass in arguments to initialize our field values too. So we'll need parameters in our constructor for an EVC. And I'm just going to use a keyboard shortcut to insert this because I'm kind of lazy, and it'll save a little bit of time. So on a Mac, Command N, on Windows or Linux, Alt Insert brings up the generate code shortcut. And I'm going to generate a constructor with parameters for all 4 of my fields. So there's my EVC. Next, I'm going to do a toString because it's nice to have a string representation of my custom class objects I'm going to be making. So I'm going to override my toString inherited from object. And all I'm going to do is just return a string representation of my object, which is simply going to be a comma-separated list of values. All right, that's good for now. This is kind of minimal working example of a publication here. I could add some getters and setters, but I don't need those for this example. So this is enough to start making a few publication objects back in publication tester. So here I'm exercising my DVC, and here I'm going to exercise my toString. And next I'll exercise my EVC. I'm just making up strings here. I don't really care what I put in here. Some title, some publisher, say this say this publication has 100 pages and maybe it costs, I don't know, $9.99. And then these kind of light gray labels here are inserted by IntelliJ, by the IDE. These are not part of my source code here, okay? See, I can't really select them. So not part of the source code, just a little label that's inserted by IntelliJ that I think is kind of nice and I leave. But if you want, you can go to your preferences or your settings and turn those off. All right, let me print out P2 here and run this. So here's the output from my toString for each of my 2 publication objects. So just a comma separated list of my field values. All right, so we've got a minimal working example of a publication here. So now it's time to talk about inheritance. Let's do this in publication. We'll do it at the top. So here's my definition of inheritance. You might have heard a different one, that's fine. This is just a really short one that I think works fairly well. So inheritance is a relationship between 2 classes. And in this relationship, one class includes, and I'm going to put AKA inherits, state and behavior from the other class. Notice that I put and in all caps. So state is like our fields and behaviors like our methods. Together these are our members, right, of our classes. So in inheritance, in Java, we inherit both the state and behavior. And the reason why I'm making a clear distinction about this is because a little bit of a preview of interfaces. Interfaces only work with behavior, not state. So I see students sometimes kind of confusing inheritance and interfaces. Well, I'm not going to talk about interfaces in this video. A little bit of a preview is one key difference between inheritance and interfaces is when you inherit from a class, you get its state and behavior. When you conform to an interface or you implement an interface, you only get its behavior, its methods. But that'll be in a different video. Today, we're focusing on inheritance. Okay, so what we have right now is an inheritance hierarchy, even though we haven't subclassed publication, okay? So I'm going to draw just like a little ugly diagram here. It'd be nicer if I had a whiteboard or use some drawing tool, but I'll make it work here in the notes. So right now, publication inherits from object. Said another way, publication is a subclass of object. Every class in Java inherits either directly or indirectly from object. Object is like the granddaddy superclass of everything. So implicitly, even though on my class header here, my definition, I haven't put anything saying, hey, publication inherits from object or publication subclasses object, it's implied, right? This extends object. Extends is the keyword used in order to identify an inheritance relationship between 2 classes. This is here implicitly, okay? I can be explicit and I can write it, but even if it's not here, publication extends, publication inherits from object. So I already have this inheritance hierarchy here. That makes a little bit of sense as well because we know about toString, right? We inherit toString from object, which is why we have to override it in order to provide a custom definition of toString for our more specific class, publication. All right, so we can add another class to our inheritance hierarchy. Let's say that we add a book class, and a book is a more specific publication, right? I could also have, draw this out again. I could also have another subclass of publication. I could have, say, a magazine, right? So both a magazine and a book are publications, and a publication is an object, okay? Think about that is a relationship. Another classic example is animal. So you could have an inheritance hierarchy where, let's say, you have a dog that is an animal. Dog subclass is animal. Dog inherits from animal. Let's say you also have a cat, right? Another example is an account. You might have a general account, but you could subclass an account to make a more specific savings account or a checking account. okay? So this is kind of the idea of inheritance. Now, I've been using quite a bit of terminology already, so let's go through and see what that terminology means. So I've said the word subclass, which is also known as a derived class, which is also known as a child class, okay? So a subclass, for example, would be publication. Publication is a subclass of object. Another example would be book. Book is a subclass of publication, okay? So think about the definition as well, right? So in the definition, one class inherits state and behavior from the other class. So this first part of the definition would be the subclass. The second part of the definition would be your superclass. And some other terms for superclass include base class and parent class. These last two here, parent and child, those are probably the most intuitive, right? Because if you think about inheritance in terms of like a familial relationship, right? Child inherits, genetics and traits and behavior and things from their parents, right? And their parents inherit that from their grandparents, right? So it's like if you followed the line all the way back to like the beginning of humankind, then that would be like the object class, right? It's the great ancestral origin. Okay, so time to introduce some specific keywords related to inheritance. So we've seen extends. So this establishes a inheritance relationship. Next we're going to learn about is abstract. So we can have an abstract class or an abstract method, and we're going to do both in the video today. So an abstract class is a class that cannot be instantiated. So let's say I make publication abstract, okay? Now I can no longer make publication objects. The idea behind doing this is, for example, let's say publication is too general in order to be instantiated. So think about this in terms of real-world objects, right? We don't have a generic publication. We have something more specific that actually exists concretely in real life. Go back to the animal example, right? We don't have just a generic animal like walking around, forest or the safari or whatnot. We have something that's more specific. But there's a lot of shared state and behavior amongst all cats and dogs and birds and hippos and bears and all sorts of things that we could push up into a superclass like animal that would be shared amongst all dogs and cats, right? Like, for example, all animals have a species, right? And they have a label maybe corresponding to what group they belong to, like mammals or amphibians, right? So we can push that all up into a generic animal, but animal is too generic to exist in real life, to be instantiated. All right, so we're going to leave publication abstract, which means we've broken our code, right? I just said that abstract classes cannot be instantiated. So where are we instantiating publication objects? Well, we're doing that over here in publication tester. So you can see that this code is broken. Here's the compiler error. Makes sense based on our definition. So we're going to leave publication abstract. So let's just comment out this code or delete it. Okay, it's illegal now. We can't make publication objects. A general publication is too general. We're going to require that subclasses of publication be instantiated instead of a publication itself. Okay, fantastic. So now let's start working on expanding our inheritance hierarchy. Let's define a book, right? We can't make publications anymore, but we could subclass publication to make a book class, and we could make book objects, unless we made book abstract, but we're not going to do that. So I'm going to head over to my source folder and make a new book class. All right, so I want book to inherit from publication, right? I'm trying to establish this relationship right here. So I'm going to use the extends keyword to establish that relationship. So now I'm going to have book-specific fields and book-specific methods or book-specific members of my class to be more general. So let's say that books have authors, but not all publications have authors or a single author. So for example, a magazine, right? A magazine wouldn't have a single author, but a book would. So this is not something we'd push up into publication, something we'd leave down here in book. And I know my example isn't perfect, but we'll run with it. There are a lot more examples online. Very commonly, like I said, the animal or the account class examples. So I tried to provide just a little different one here so that you can still use those ones and start generalizing your knowledge of inheritance. All right, so let's add our constructors. I'm going to go a little bit faster here. So public book, we'll do our our DVC. I'll have two EVCs because I'm going to have one that just accepts a single author. And then I'll have one that's going to accept all 5 field values, right? 4 for my publication and 1 for my book. I'm doing shadowing here, so I have to use this to refer to the field, not to the local variable, the parameter author. Okay. So before I move on to my last constructor I'm going to put in here, we need to talk a little bit about initialization, right? So book has 3 parts to it now, right? It has an object part, it has a publication part, and it has a book part, right? So all 3 of these parts need to be initialized. So what Java does actually for you is it calls superclass constructors implicitly. So I'm going to type that here. Java calls your DVC for publication. I'm going to put more generally in here, your superclass constructor implicitly. Okay, even if I don't call my superclass constructor, it's going to be called. So what's nice about this is I don't have to do it, but I can if I want, right? It's like that extends object I was talking about earlier. So what does this look like? This looks like this. This is a call to your super DVC, okay? I want to emphasize that super is a keyword, just like extends is a keyword. I'll even put it here. I'll say super is a name or a keyword for the superclass type, okay? I'm saying superclass type here just to be really explicit. So super is not a reference to an object. Sometimes I see people think about super like this. They are not the same in any regards, okay? They're only in the same that they're reserved words, right? They're keywords in Java that have special meaning, but this is a reference to an object. Super is not. Super is just an alias or a different name for your superclass type. Okay, so one quick demo here. If you decide to explicitly call the superclass constructor, which in this case is optional, it has to be the first line of your constructor. If I move it, say, to be the end of my constructor, I get an error and it says call to super must be the first statement in the constructor body. Okay, so if you see this, I'm like, oh, okay, I just got to move it up here. And this is kind of following the idea that you should initialize higher up the hierarchy first, right? Initialize the more general things before you initialize the more super things. Or excuse me, sorry, not the more super things, the more specific things. So you might be initializing something in book that's dependent on something initialized in publication, right? So start initializing higher up the hierarchy, be more general before you're more specific. Okay, so here I don't have a call to super. Remember, I don't need one. It's implicit. But in some cases, like in this next EVC I'm going to do, we do need to be explicit and we do need to call our superclass constructor. So right here, I'm accepting 5 parameters, 1 for my book specific field and 4 for my publication specific field. So I've got to invoke my superclass EVC, write this call to super EVC, in order to propagate these values up my inheritance hierarchy and get them initialized in the constructor publication has to offer I'm not going to be initializing publication fields here in book, right? That's publication's responsibility. All right, next thing we're going to do is make some book objects. It is time. We're going to come back and customize our toString here, but let's make some book objects and see how they look. All right, so if I run this, I'm going to see output from a toString for each of my objects. Okay, this toString that's being invoked is the toString inherited by book from publication. Okay, this string right here is being implicitly called from our print line because a string representation of our object is needed. And book doesn't have its own toString. It didn't override publication's toString. So what's being returned is the string from toString and publication, this right here. All right, now let's go override publication's toString in book to provide a more specific string representation of a book, right? And that might be everything a publication has. In addition, it will have the book specific state, which is author. So Control O brings up your override methods. It's really nice because it shows you what's available to override. And it also shows you the different parts of your inheritance hierarchy, right? Remember I said we have an object part? Well, here's everything we inherit and haven't overridden from object, right? Here's our object part of book. And we have a publication part. And here's what we have available to us to override from publication, right? So here's our publication part. And I want to override publication's toString. So all I'm going to do is reuse all of that behavior that I coded up in publication's toString by calling my superclasses toString, which is publication. You can see that here. And adding on a comma-separated list of my field values. Well, I only have one field value, so that's author. Okay. This is really important to reuse your superclass toString if possible. Otherwise, if I were to type back out everything like title, comma, publisher, etc., that would violate the dry principle, right? Which is don't repeat yourself, right? Reuse your code when possible. All right, now I'm going to run this, and I'm going to get output now from books toString. And I know that because now I have an author tacked onto the end, whereas a publication doesn't have an author, only a book has an author. All right, so the next topic is an abstract method. Actually, let's do this in publication. Right up here. All right, next topic is an abstract method. So this is a method without a body. Okay, it looks a little strange. That must be implemented in the subclass. Okay, only abstract classes can have abstract methods. Publication is an abstract class, so we're going to add an abstract method. Abstract methods are a great way to enable polymorphism, which we're going to talk about as our last demo at the end of this video. All right, so let's do an example of an abstract method. So I'm going to have my method header, public abstract, and then my return type. And I'm going to go with a very simple example here. Let's say that all publications have to have a generate copyright method. But let's say that publication is not going to provide a default implementation of generate copyright because a publication is too general to even have that information to generate a copyright for all of the different types of specific publications like books and magazines. Okay, so this is an abstract method. It doesn't have a body, right? There's no curly brackets after my header. And so there's a semicolon. And if you've done anything in C and C++, this kind of looks like a prototype, right? So this is a header for a method without a body. So the requirement is subclasses have to provide an implementation for generate copyright. If a subclass is also abstract, then they don't have to. They can still inherit this abstract method. But if they're a concrete, meaning a non-abstract class, they have to provide an implementation of generate copyright. That way, all publication references, regardless of whether they refer to a book object in memory or a magazine object in memory, they all can use generate copyright because it's mandated that all publication objects, right, which are really book or magazine or etc., have a generate copyright. And I'll show you this in action and explain it again with some notes that are a little more tangible than me explaining it here. Okay, so now we've broken our code, right? Because I just said that all subclasses have to provide a generate copyright method implementation, or they have to be abstract. Well, book is not abstract, and we don't want it to be abstract because we want to be able to actually create book objects. So here's the error that I'm getting up here. It says what I've been saying out loud, but in writing. Class book must be either declared abstract in order to inherit an abstract method, or implement abstract method generate copyright. So we're going to do the latter, right? Let's go down to the end, and we are going to pull up our override methods, Control O, and look, there's generate copyright. We're going to override it and provide an implementation for it. My implementation is going to be very simple. I'm going to say to do generate books copyright. I'm not actually going to do it. The point is to demonstrate that we can have this method and we can call it with just a publication reference, which you'll see here shortly. All right, so just let's run it and make sure nothing's broken. All right, back in publication tester, I can now do something like b2.generate copyright. There's that string being returned from generate copyright. I could also do something cool like this. I could have publication P1 is assigned B2, okay? So I just want to emphasize P1 is a reference to a book object, and that's actually the same book object that B2 references. Okay, I'm not making a publication object. I can't make a publication object because publication is abstract. But I can treat all of my books like publications because of inheritance, right? So now, when I do something like P1 dot, I'm going to see everything that a publication reference can see, right? Which is the publication part of a book object, right? So right here, here's generate copyright. This is kind of leading up to a big polymorphism demo that's coming here shortly, but this is just a little bit of a preview of how we can have references to objects, and the types of those objects can be determined at runtime, and the behavior, therefore, can be determined at runtime. Okay, back to publication. So I said we were going to do two subclasses of publication, book and magazine. So now it's time to do magazine. And I'm going to do this somewhat fast because it's really the same as book. In fact, if you want, you can pause the video and try to do magazine yourself. That'd be great practice. Magazine is a publication, but more specifically, a magazine has a publication frequency, right? Like magazines are published weekly or monthly or semi-annually, whereas a book doesn't have a publication frequency, right? A book is only published one time, theoretically, for my example. All right, so time to make a magazine class. I'm going to set weekly to be my default publication frequency doesn't matter too much. Oh. Got to put my extends publication up here so that I can see all of my publication fields. Okay, so I've still got an error here, but I want to show it to you before I resolve it. So up here it says class magazine must be either declared abstract or implement generate copyright. This was the same thing we saw for book, right? Because I've established an inheritance relationship between magazine and publication, magazine has to provide a generate copyright in order to compile, or it has to be declared abstract. But I don't want to make it abstract because I want to make magazine objects. So I'm just going to do another really simple generate copyright. Fantastic. My compiler error is gone, and now I can make magazine objects. All right, so right here I'm printing out M1, a reference to a magazine object that's been initialized to all default values, and I can see that I'm getting the toString from magazine because here's my publication frequency on the end. Whereas here I'm getting an author on the end, which is my books toString. Okay, but this part right here is being reused from publication by both of my toStrings in book and in magazine, which is pretty cool. All right, so now it's time to kind of pull this all together and talk about polymorphism and dynamic binding. All right, so polymorphism. I'm not going to claim to be a Latin expert, but poly means many and morphism, means to change or, some sort of different behavior. So I'm going to put in what I always think of when I think of polymorphism is same code, different behavior, okay, which is kind of a, derivation of the root words in polymorphism. All right, so an example of same code, different behavior. Let's say I have an array of publication references. This is going to be kind of small, I'll just do 4. Okay, recall that this line of code does not actually make any publication objects. It allocates room to store 4 references to publication objects, right? Publication's abstract. We cannot make publication objects, but we know that our subclasses of publication, like book and magazine, if we make a book object, a book has a publication part to it, right? So we can get a reference to a book object and treat it like a publication, right? So this is going to be a great example of polymorphism, where we're going to have the same code for books and magazines using a publication reference, but at runtime we're going to get different behavior depending on whether that publication reference refers to an actual magazine object or an actual book object. All right, so let's say pub sub 0 is going to refer to B1. Let's have pubs sub 1 refer to P2, and let's have pub sub 2 refer to P1. And recall that P1 refers to the same object as B2, right? Recall this statement up here where we made an alias to B2's book object with P1. And then lastly, let's set our last reference of our pubs array to refer to a magazine object, M1. So it's nice to draw pictures to show the memory map here. I'm not going to draw a picture, but I can kind of code it up using comments to help describe what's going on here. So we have a book object that is referred to by B1. Okay, We also have a reference in our publication array, specifically the reference in pubs sub 0, that also refers to this book object. Okay, so B1 and pub sub 0 refer to the same book object. That one's pretty straightforward, but we have a second book object, and this one is referred to by B2. Okay, this one's also referred to by quite a few other references, right? Recall up here, our general publication reference, P1, also refers to the same book object as B2. All right, we also set pub sub 1 to refer to the same book object as B2, so I've got to update this. So pub sub 1 also refers to this book object. And we said pub sub 2 refers to the same publication object that P1 refers to, which at runtime, this is actually going to be a book, right? So here's one more reference. We have pubs sub 2. Move this over a little bit. Okay. Do this. Wonderful. All right, so here's a memory back for our two book objects. We've got a lot of aliases for our two book objects, right? We also have a magazine object, which is referred to by M1. And it is also referred to by pub sub 3. This is going to help us decipher our output when we use a generic range-based for loop to iterate over all of our publication references. And at runtime, those are going to resolve to different types of publication subclass objects. All right, so let's do it. So we've got a range-based for loop. So for each publication P in pubs, okay, let's print out p.getClass separated by p.hashcode, which we'll use the hashcode to help identify which object we're looking at here. Then let's just print out our object. This is going to invoke toString on the object, okay? So we have a general publication reference P that points to a magazine or object, and at runtime, dynamic binding is going to resolve to the actual object type, okay? So right now, at compile time, called static binding, right, P refers to a general publication object, okay? But at runtime, P is going to be bound dynamically to an actual magazine or an actual book object as we set up our references here. And the last thing I'll print out is p.generateCopyright. I think this is a great example of polymorphism as well, right? Because publication doesn't have an implementation for a copyright, but we're working with a publication reference. So with dynamic binding, at runtime, this same code is going to give us different behavior, and we're going to see book or magazine specific copyrights being printed. And I think I'll actually put a little separator in here so it's not all jammed together. Okay, still want to be able to see our memory map here. Oh great, it all fits. Okay, so here, our first publication reference in our array refers to a book object, and here's its hash code. Okay, here's the toString for book being shown, and here's book's copyright. Okay, so pub sub 0 refers to this book object, which we see has this hash code. All right, pub sub 1 and pub sub 2 refers to a different book object, which we see here has this hash code. See how it shows up twice? That's because we have two references to the same book object. This one, the one we initially created with B2. Okay, so this all makes sense here. Great. Now, down here, we have a publication reference to a magazine object. Note, it says class magazine, and it has a different hash code, obviously, because it's a different object. And we see here we're getting output from magazines toString. Okay, that's coming from this line right here. We're printing out a general publication reference, but at runtime, this is dynamically bound to a magazine object, so it resolves to magazines toString in order to get this output. That's how non-static methods work in inheritance. That's not how static methods work in inheritance, but we're not going to worry about that for now. All right, and then right here, I'm seeing the string return from magazines copyright. Okay, so same code, all of this right here, same code, specifically right here, different behavior, right? We're getting a different toString, we're getting a different copyright, even though we're using the same reference type publication. That's inheritance and polymorphism and dynamic binding in action. All right, so that is the conclusion of the Inheritance Fun demo. We went through a lot. There's a lot more details, but this is a good crash course in what is inheritance, how do we code it up, why do we code it up, and also what does it give us, right? Polymorphism. It allows us to treat our magazines and our books the same because they're publications, right? They have a publication part. So we can access anything with a general publication reference that all publication objects have to have, right? And we can also access different behavior that's coded up specifically in each of our subclasses using the same reference, right? A publication reference. Very cool. All right, that's the end of the video. Thanks for watching. And if you have questions, feel free to ask them.